Hello everyone. Today in this video we are going to be going over a brief introduction to encryption. So encryption is a topic that has been with humanity for thousands of years. And the main problem that encryption seeks to solve, or the main task that encryption assists with, is one person communicating a message to another person. Now this main process of communicating the message is a pretty trivial task. It could be done with a variety of methods. It can be done, maybe in the ancient times by sending a note, sending a letter. And in modern times, it can be done via sending an email. Now, the main problem that encryption tries to solve, though, is what if somebody is intentionally listening in the middle? Somebody is opening the letters illegally and reading the contents. Somebody is intercepting the email with some ways, like, for example, setting up a bug in midway, or listening to the traffic coming into or out of a server. So the main problem you can see is how to keep the message sent secret, even if it is read. So this is done via encryption. So encryption consists of two processes, encryption and decryption. So encryption essentially turns the original message, or the plaintext, and plaintext doesn't have to be plain English like it is in this example. It can just be any information that the two parties want to kept disguised. And through encryption, the plaintext is turned into ciphertext. It's turned into a form that is really hard to understand or make any meaning out of if read by a third party who does not have the methods to understand this message. And the method of understanding this message is called decryption, so turning ciphertext back into plaintext. And you can imagine that, in this whole process, some piece of information or some process or some method is used to turn the plaintext into the ciphertext and to turn the ciphertext back to the plaintext. And this is what we call a key. So this key will be some piece of information that's used to transform the message between the two forms. So let's visualize this with an example. So one famous method of encryption is the Caesar cipher. And the Caesar cipher, as you can probably guess from its name, was used by the Roman general Julius Caesar. And basically Caesar cipher, what Caesar cipher does is it substitutes each letter in the original message into a different letter. And it does it with a very systematic way. So basically it takes the order that these letters are in the alphabet. So for example, H with H, and we want to basically shift it forward by a number of times. So if we want to shift H forward once, we know that the letter after H is I. So basically H turns to I, and E would turn to F because in the alphabet F is after E. And for the L's, it would be L, M, N, O, P. So L turns into M, and this is true for both of the L's, and O turns into P. So in this context, in the Caesar cipher, the hello would be the plaintext, and the ciphertext would be, IFMMP. And what would be the key in this scenario? Well, the key in this scenario would be the method that was used to turn hello into IFMMP, which is the shift, which in this scenario is 1. So as you can see, in this scenario, the key is basically the information that the shift used was 1. So what if Alice wanted to send a message to Bob? So Alice wants to send the message hello to Bob. And she also wants to hide the message in a way that, if the attacker reads the message, they can't make any sense out of it. So she encrypts the message into this mumbo jumbo. And this goes to both the attacker, since the attacker is listening, and to Bob. Now, Bob basically takes the key used during encryption and basically just applies the reverse to it. In this context, Bob would just shift everything by -1. Bob would just shift everything back by 1. And Bob would eventually, if he does that, he would come to the original message. Now the attacker, he or she cannot do that. Why? Because the attacker doesn't have the key. So this method of encryption is called symmetric encryption. It's called symmetric because it's symmetric on both sides. The same key is used for both encryption and decryption. Now, symmetric encryption, the benefit of it is that it's really simple. There's only one key that has to be used, and usually the method used to encrypt and decrypt is pretty trivial, like in this example. But symmetric encryption also has a lot of weaknesses. So as you can imagine, if the key is leaked, then the attacker would be able to decrypt any messages that are sent between Alice and Bob. And not only that, they also have to devise a method for communicating the keys in the first place. This could be done via maybe Alice meeting Bob in real life. And during their meeting, they would agree on a key to use in the future. But what if Alice and Bob cannot meet in real life? Then symmetric encryption wouldn't be able to work because they wouldn't be able to agree on a key in a secure way. And this is the problem that asymmetric encryption, so non-symmetric encryption, tries to solve. And in asymmetric encryption, there are two keys that will be used. One will be the encryption key. And then there will be a decryption key. And the encryption key will be used solely for encrypting the message from the plaintext version into the ciphertext version. So that is the only thing the encryption key will be used for. And this key, realistically, it can be known to everybody. As long as the two keys aren't associated, this encryption key could be known by everyone, including the attacker. So in cryptography, we tend to call this key the public key. And the opposite of public is private, so the decryption key is kept private. And you can imagine why the public key is able to be public. If an attacker has the ability to encrypt messages, then they wouldn't be able to do much with it as long as the two keys, the two processes aren't associated. But the private key would be able to be used for decrypting messages. So let's see how this process is more powerful than symmetric encryption. So let's say that in this, with the same example, Alice wants to send a message to Bob. In this scenario, they would use Bob's public key, so Bob's encryption key, to encrypt the message. So say Alice starts with hello again, and she would essentially use Bob's public key that is public to everyone. And of course, Bob probably at some point broadcasted his public key to everybody, or maybe sent it to Alice. And Alice, or both Bob and Alice, are in possession of Bob's private key. So Bob private key, and Alice and Bob both have it. And this is used, as we remember, to turn this plaintext into ciphertext. So yeah, remember I wrote private instead of public, sorry about that. Hold on, let me delete this box. Public key. And this public key is used to turn the plaintext into ciphertext. And everybody has access to this public key. And when this message is encrypted with the public key, just pretend this is a message encrypted in a more secure manner. This is sent to Bob, and it is decrypted with the decryption key, which is the private key. And this is the key that only Bob has. Not even Alice has it. Nobody needs to have it to send encrypted messages to Bob, because in this process, only the public key needs to be used to send messages over to Bob. Now, to visualize this situation a little more vividly, we can use a simple metaphor. So say Alice wanted to send Bob a message which is in the form of a piece of paper locked in a box. And in this case, the private key would be the lock used to lock the box. So the lock is the public key. And everybody would have a copy of this lock. And it would be Bob's lock specifically, so everybody could use it to send encrypted messages to Bob. But only Bob has the key to that type of lock. Only Bob has the corresponding private key to Bob's public key. So only Bob would be able to open the lock, would be able to essentially decrypt the message and find the plaintext. And many encryption methods by this description are used, including stuff like RSA, a number of different encryption methods, and all of them essentially work in this or in a similar way with a public key and a private key. And in a future video, we'll probably discuss such methods in more depth. I hope you learned something from this video. Goodbye.